Thanks for joining us for this exciting machine learning infrastructure on Dell PowerEdge servers webinar. We will be covering a lot of content, high level as well as technical contents. So you are here for a good ride. As for introduction, my name is Kishore Gagrani. I work for Dell Technologies in its PowerEdge server group as a product manager, who's responsible for emerging and new technologies for PowerEdge. Let them introduce themselves, my co-presenters. So Alex, why don't you start introducing yourself?
Great, thank you very much, Kishore. My name is Alex Arnaldi. I am a solutions architect specializing in software-defined infrastructure, primarily wrapped around Kubernetes, a couple other joining technologies, machine learning and artificial intelligence and GPU product manager, Alessandro Festa. Opportunity to introduce himself.
Thank you, Alex. So, hi everyone, I'm Alessandro Festa, Senior Product Manager for Artificial Intelligence and GPU accelerators at SUSE. And I'm super excited actually to help Kishore and Alex to drive you through this journey around AI and latest technology with Dell. And with that, back to Kishore.
Thanks, guys, Alex and Alessandro. So with that, I wanted to set up a stage. It's going to be a very quick intro into what we are planning to cover today. So we're going to go over a very high level on machine learning, what it means as a process in terms of pipeline, as we call it. Then we're going to start diving into the architectural considerations, and we'll spend a lot of time on Kubeflow, specifically around how to deploy it and some other technical considerations while you're deploying Kubeflow for your machine learning. And we'll end the presentation with a good live demonstration of Kubeflow running on PowerEdge servers. So with that, let's get into it. So in terms of machine learning pipeline itself or process, so it's quite often termed as machine learning pipeline. You see the data creation to all the way to archival. Data creation through data transmission, all that is generated, all that data is generated using your own applications. If you are in, for example, in a financial industry, you could be having an application, enterprise application running fraudulent detection of a credit card. If you are in a, let's say, insurance company, and you could be running an application which constantly monitors the churn of customers' churn on insurance. If you are in a manufacturing industry, you could be working with your ERP system to see what's the anomaly can happen in terms of functioning of different stages of the manufacturing. The point is, there are many customer-driven applications you run in your environment and which generate data, a lot of data. Once that data is generated, what do you do with the data? And that's where the right side of this machine learning pipeline comes in place. Someone needs to get that data, ingest it, clean it, stage it so that it can be analyzed, modeled, and create some sort of a visualization or infer some decision out of the data so that your industry can make a better decision out of it. And once it's all done, you want to archive it not for just keeping the data, but also for many regulatory purposes as well. So keeping that data, the machine learning pipeline in mind, there are several tools available specifically around starting with data integration to the archival, which will help you do this analysis. And at Dell, we are partnered with multiple software companies to help you do that. So we have partnered with a company called Iguazio, which are world leader in ML ops. Yes, there's a new term called ML ops, like DevOps, so that you have a continuous churn of machine learning models as the newer data comes in and you're constantly getting a new feed. We partner with world's leading organizations, Data Robot, H2O. So we can help you with any of these implementation with Iguazio, Data Robot, or H2I when it comes to machine learning pipeline. Last but not least in this one is Kubeflow. And Kubeflow is an open source tool which is available for machine learning pipelining. You can do data staging all the way to visualization of data. And that's the focus of today's webinar, where we're going to go deeper into if you decide to have open source, everything open source in terms of machine learning, or combination of open source in some of these licensed software, you have a choice. And at least we are going to present you how do you going to do Kubeflow in your environment in today's presentation. Software doesn't run on itself. It requires hardware. So Dell's been known for the remaining stack of this presentation, which is we have our servers, storage, and networking. We support Intel-based CPUs, AMD-based CPUs. By the way, talking of CPUs, I don't want to call it a myth, but at the same time, there is a growing perception that when it comes to machine learning pipeline or machine learning workload, you have to have GPUs, which GPUs help. And they do, and especially when it comes to deep learning or inferencing or some visualization, text to image conversion, GPUs are very helpful. But many of you will be surprised, many of your workloads on machine learning can just run on CPU. So keep that in mind, when especially when you are in IT shops and you're concerned about cost of running a hardware with the expensive GPUs in the server. Evaluate your workload, whether it requires GPU. If not, can you just do with servers with Intel or AMD CPUs? So Dell has portfolio of servers. Depending on where you are, how do you need it, we can help you put the right server at the right place in the machine learning pipeline. We got extensive amount of storage portfolio with our EMC acquisition. We got software-defined storage. We got traditional SAN-based storage like PowerMax. In software-defined storage, we got object storage from EMC. We got file storage for Isilon. We got HCI portfolio, VxRail, and VxFlex, right? So Dell's got slew of options available for your storage needs, and as well as your networking need for switches and stuff. So we got you covered from all the way from data creation in the machine learning pipeline to archival. So that's why we call it end-to-end machine learning pipeline. Well, it would be just fine if we just had this. The data scientists themselves, if you are the data scientist, you do not have a server for yourself. You have a workstation. And that's where we got our the consumer-facing workstations and laptops for your disposal, where you can run your many tools, which we'll talk a little later with collaboration with Souza. You can use those tools, push those data out of those tools into this pipeline, which is a cluster, right? And last but not least in this slide is services. So while you can do all of this yourself, of course you guys are competent, but at the same time, Dell services are here to help you deploy this stack of hardware and software in your environment if you need services. We also partnered with a company called Grid Dynamics, which is a world's leading company for machine learning, modeling and designing of the machine learning data in your cleansing the data or any sort of software development. We partnered with them to help you with the machine learning process. So with that, having said, set up the whole architectural overview, just quick go one level deeper into it. In a typical, if you're deploying a machine learning on-prem infrastructure, there are three top considerations you need to take care of. One is an application node where your Kubeflow and all those will run. Then there's a compute node where you will need a lot of data which is coming in and analyze it. And then there's a storage in the backend where you will keep your data stored, or the data is coming in at that storage place as well from multiple sources within your enterprise. So here we are depicting those three cluster of nodes. So you got master nodes running your Kubernetes for management and orchestration. In our testing, we did it on 3 Dell server nodes, each with a 20 cores of CPU, about 512 gig of memory, and some minimum storage for your boot and stuff. Then we got worker nodes where you got a compute of the data analysis happening. And that we ran on 4 servers, each again with 20 cores of CPU each. Actually, each CPU, there are 2 socket CPUs, so there are 40 cores per node you get. About 512 gig memory and some amount of storage in there, because you might want your containers not to be stateless in this one. They need to be stateful, then you need some storage here. And that's why we kept some fast storage here at 1.6 terabytes NVMe storage. And on the back end, we had it all on the Ceph cluster. So keeping the open source theme, we, instead of going for our own storage, we thought it will be helpful to test an open source based storage. So we chose a Ceph cluster with SUSE Enterprise Storage, SaaS, as it's all commonly known as. We had it on 4 nodes running on 20 cores of CPU, which is not that big and important here, especially because it's all hard drive based storage. So slow storage, but that's what we went with. And then you need some management server. It could be virtual machine running on one of those as well, but you're looking for things like DNS, DHCP, IAP, time protocol server, because timing in the Ceph cluster is extremely important and stuff like that. So with that, that's at a very high level, the architecture, what we tested in our lab, and we're going to go over that architecture in the rest of the session today. And by the way, this slide just talks about how we collaborated with SUSE on several components on their previous slide I shown. So for storage, we use their SUSE Enterprise Storage running on Ceph. For their cluster management for the Kubernetes, we use their containerized service platform. So we're going to go in detail of each of these things in the next few slides. So with that, Alex start talking about SUSE's CaaS platform, which we did on our compute side of the cluster. So Alex?
Right. Yeah. Great. Thank you very much, Kishore. So the first thing I want to point out with our base architecture here is how we segregated the networks. We have the security sensitive iDRAC network separated from the high bandwidth storage network, and that of course is segregated from the low latency Kubernetes data network. I also want to mention that our 3 master nodes are set up in a highly available fashion, and they were a perfect fit for the Dell PowerEdge R640 servers. While the worker nodes needed the additional performance of the Dell PowerEdge R740 XD2 nodes, these can be equipped, as Kishore mentioned, with GPUs or without. In our case, we had GPUs for some of the training work that was done. Aside from that, the rest of the work was done strictly on CPUs. Now, one of the things that is probably the most important to know about CaaS Platform is that we maintain SUSE CaaS Platform as close to upstream Kubernetes as we can. Now, that's both in code base, but also in release schedule. So other distributions of Kubernetes are going to fall several releases behind. They're going to actually maintain themselves several releases behind, which is going to be behind in features and in security fixes. So when you invest in SUSE CaaS Platform, you don't have to worry about that. You can get the most modern features along with advanced software like Kubeflow, and we've already proven and tested it on our releases. And with our SUSE Enterprise Storage cluster, you also see we have that same network segregation. And again, the same nodes. We have our highly redundant monitor nodes and our worker OSD nodes, which maintain the storage and do the storage I/O. But I also want to just point out what a very small footprint we have here for a highly redundant storage cluster. You get all the bandwidth of the four PowerEdge R742 footprint here. And of course, we keep SES very closely aligned with upstream Ceph as well. And now I'd like to pass on to Alessandro to continue on with our Kubeflow and Dell and SUSE ML deployment.
Thank you, Alex, and thank you to Kishore. So yes, so far we explained the infrastructure backend, how we build this infrastructure and this AI platform on top of it, namely Kubeflow in this case. Also, Kishore did a great job actually to explain how if you're a data scientist, you can start from a Dell workstation, from a Dell laptop, and you can start actually working your models there, and then later push those models directly in the platform. Again, in our case, in this PSU, in this environment, Kubeflow. Now, what we're going to present basically is the idea to make the life both of the data scientist and the ML operator or AI operator simpler. What does it mean? Well, it means that the data scientist shouldn't care about configuration and complexity, but should focus only on his job, on deploying and modeling his or artifacts, and then easily move them to the infrastructure where the computational node can help him out to get the expected outcome, while the AI operator, the ML operator, actually should focus on the deployment phase and later on the monitoring phase. That means that he should simply look at what it counts for him. As an AI operator, he should focus on the platform and how the platform runs, how the pipeline and the runs there are executed, if they're executed successful, or if there's any issue, it can potentially debug that. So we will guide you through a small demo we set up that actually explain you this end-to-end scenario using Dell and SUSE together to provide you this complete solution. Just a couple of points more about that. From the operation standpoint, what you see is Kubeflow that is running on Kubernetes. SUSE is collaborating upstream now with the Kubeflow community to make Kubeflow running on the latest version of Kubernetes. That, as Alex pointed out, is what we're already doing with the CaaS platform. Also, we are targeting another kind of platform that is our high-performance computing, where again, you can leverage the same scenario, the same solution. Again, starting from the very Dell workstation or laptop, the SUSE AI playground, along with the infrastructure that you need for the use that you need. Now, to do so, let me jump on the next slide. So what you're going to see here is basically this demo. We will start from the data scientist. We will select an editor. Then we will select the template that is the AI platform we want to work. We will land on the templates. We will use a preset templates for that. And then we will show that the pipeline has been uploaded. Later, we will move to the AI operator to see what the AI operator can see and how you can interact with that. So the data scientists select the editors. You see multiple variations of that. Once he got the editors, what he knows, he will go for the templates. What kind of platform you have on the backend. Once he's selected, he will land on a pre-built templates for him. In our case, we already done all the coding here, and we just need to execute the last cell. That simply says, please upload this pipeline to Kubeflow environment for me. You see that a link has been created for me, and the pipeline appears directly in the Kubeflow pipeline site. Now let's take a look at the AI monitor, AI operator. He can actually see what is relevant for him, the pipeline that I just uploaded as a data scientist, or the runs, to know is actually if they are successful or not. There's one error here, for example. And I can click on that and click on the details so I can immediately start to debug that. You see in few seconds how everything was seamless. Everything was easy. That's because behind the fully integrated environment within Dell and SUSE had put out, And because the playground make the data scientist, the operator, to focus on what really matters. And with that, I will hand over back to Kishore for a very last comment before I end up this session.
Thank you, Alex and Alessandro. That was wonderful. By the way, if you all noticed, everything Alessandro demoed was running on exact same infrastructure, which we overviewed before he started the demo.
Absolutely.
Meaning everything was running. If
you allow me, everything was running on Dell, and that was the beauty, that everything was so simple to set up between Dell and the SUSE support, and that actually relieved all our customers from the complexity of making such environment ready to run. Very true, very true. And there's a couple of things to point out when Alex was going over SUSE CaaS cluster, right? R740XD2, we had, it's a hard drive, all hard drive based server. You have a choice to use whichever compute you want and whichever storage server you want. Where all the components you saw, Kubeflow and SUSE's CaaS and SUSE's CaaS, all those components are open source. So just keep something in mind, that if you want to go all open source, come to Dell and SUSE and combine together, we can get you where you need to be without having to worry about where your data is, because we understand that you cannot bring all your data to cloud, and hence your experimentation will fail. Whereas if you're having everything in-house, on-prem or hybrid, it's guaranteed that your experimentation will pass, plus gives you all the flexibility you need. Thank you so much for joining us, tuning in to our webinar, and thank you.